My name is Ken Jones. The following footage was taken by me when I helped to commission the Cable Belt conveyor in 1978. I offer it as a unique historical record of the system. I must apologise for the jerky screen and poor definition, but the film stock is at least 45 years old and is now rather brittle. At the time, my intention was to prepare the film as information for my colleagues at the Cable Belt office. But family life got in the way and the project was forgotten. Anyway, here it is for what it's worth, and I hope it brings back memories to those of us who are left, both here in the UK and also in Arizona. Here is a general view of the conveyor as it runs through the Arizona desert. I meant this to show how the conveyor fits in with the desert terrain. The full length of the conveyor was just under 10 kilometres, with an angle station about halfway along, but more of this later. This is Ken Atkinson arriving on site. Ken was the Chief Electrical Engineer for Cable Belt Ltd. He was my boss and a good guy to work for. He is heading up to the discharge end of the conveyor, which is where the drive house was located, together with the tension system. The gantries in the distance were part of the takeaway system onto which our conveyor delivered the material, which in this case was copper ore. As Ken approaches the drive house, one of the two motors can be seen. This is the drive house, incorporating all the electrical controls for the drive system. I think the drive was by Toshiba, and startup was controlled using a liquid resistor. Here is the motor coupling and the braking system, not useful for stopping the conveyor, but essential to stop runback when fully loaded. This is the gearbox incorporating the copy wheel drive to the hauling ropes. To provide friction to the ropes, the copy wheel rim was built up from a series of aluminium blocks, alternating with blocks of a hard plastic material. There were problems, however, which we will come to later. In the close-up of the copy wheel, it appears that the top is coming toward you, but it does in fact run the other way. It's the cine that has produced this effect. Here is the tension tower supporting the tension weights which provide tension on both the belt and the steel ropes. The guy standing next to the rope tension trolley is, I think, Tony Masters. He was the Cable Belt site manager. I zoom into the rope tension trolley to show the very slight movement of the trolley when the belt is running. This is a shot of the tension area, and in particular the belt tension trolley. I was lucky enough here to get a sequence of the trolley reacting to a normal stop. I was always fascinated by the way the tension system reacted to stops, starts and loads as the belt and rope stretched under various conditions of drive. Again, we are in the tension area looking back towards the angle station and the loading point some 10 kilometres away. As this was the commissioning stage, there were several stops and starts, and I was not always in the right position to get the best shot. But with careful observation of the close-up of the tension tower, it could be seen that the weights do move very slightly. The position of the weights in the tension tower was always changing. Even the heat of the day would change their position. Here we have the discharge drum where the material was dropped off of the cable belt into a chute located above the transfer belt. There is also a shot of one of the rope return pulleys. In the next shot, I was particularly keen to show the guys in the office how the belt was lifted off of the rope for transfer to the return line. This is the discharge structure and another rope return pulley running at what appears to be full speed. Another shot looking back toward the discharge area showing a cloud of dust, as our initial loading trials were probably using overburden, not copper ore. Now we come to the real reason why I was there. This is a shot of one of the pull keys. This is part of a system which provided an emergency stop facility along the full length of the conveyor. This was my design, using pull keys by Davis of Derby and incorporating belt dislodgement and broken belt switches in accordance with Ken Atkinson's initial guidance. I designed a plug-in system incorporating magnetic reed switches. He left me alone to design, build and test the system, and I was congratulated by the commissioning team as it was the first time a signal system had worked directly on switch-on. The only complaint I had was that the belt dislodgement plates tended to rattle when the conveyor was loaded. There may have been other problems, but I was not made aware of them. Anyway, the system was used on several other conveyors following this installation. I'm not sure what this is, but it looks like some kind of belt speed monitor. I think this is the loading end, with a nice action shot of one of the rope return pulleys. The guys peering into the loading chute suggest a mini debate about some difficulty. Perhaps it's the dust suppression arrangements, which I have focused on as well. This must be the loading area again, and as I zoom out we look along the conveyor route towards the angle station. I think that is Ken Atkinson standing beside me. Now we come to the problems which I mentioned earlier. We are back at the gearbox end, and these are aluminium chips shaved off of the coping wheel by the steel rope as it slipped in the drive slot. The hot Arizona sun has melted the grease, which is normally packed in the centre of the rope, making it unusually slippery. The solution: covering the rope with cement dust. You can see that we have a box rigged around the rope as it runs through the tension area. Into this box we are shoveling cement dust. With the conveyor running, the rope passing through the box gathers the dust, which, it was hoped, would soak up the grease and dry the rope. Now, I think, we come to the clever bit. This is the angle station where the load is diverted by 60 degrees. The material on the incoming belt, in the background, is lifted up and dropped into a chute, which is over another belt which runs off at the desired angle. Both belts are moved by the main drive, which is why we have several rope guide pulleys in this area. The incoming belt must have had its own tensioning arrangements, but I don't recall how this was linked into the signalling system. This looks like an emergency stop. Some of the material is escaping back down the takeaway belt. Here is a shot of the load on the conveyor, moving quite slowly for some reason. Then more details of the rope and pulley system working. A final shot of the loading area. I had nothing to do here, so I don't remember much about it. Nice shot of the pulley work though. I see there is a pull key link, but it looks a bit low down. So that's it. I'm sorry if my efforts lack the professional quality that we are so familiar with nowadays, but I am not a professional. I just hope that you enjoyed this piece of history, and I will be pleased to hear any comments that you may have. Thanks for watching. Cheers. Bye.